Okay, so starting with conduction, convection, and radiation. So these are the three methods by which heat can be transferred. Okay, so heat energy can be transferred by any of these three methods. When we are going to talk about conduction, what is conduction? Conduction is basically the process by which the heat energy is transferred through a solid, especially through materials that can conduct heat, right? Especially through materials that can actually conduct heat, like metals, right? Metals are good conductors of heat. So, especially through those metals that can conduct heat, uh, the transfer of heat energy is going to take place through the process of conduction. What exactly is conduction? Conduction is basically the flow of heat energy from an area of high temperature to an area of whole low temperature, right? That is what is conduction. The flow of thermal energy from an area of high temperature to an area of low temperature. When we are going to go ahead and talk about it, how does it actually happens, right? What's like the logic behind it? What is actually happening in this entire situation is this. There are two reasons why this is happening. There are two theories behind it. One theory is that what is going to end up happening that um, one theory is that when one part of the metal is heated, the electrons start to move faster. It makes sense because the electrons gain kinetic energy, right? So as the electron gain kinetic energy, what is going to end up happening? That they're going to start to collide with each other. As they're going to start to collide with each other, what's going to happen? They will transfer the kinetic energy from one electron to another. And this is how the heat energy is going to be transmitted from the area of higher temperature to the area of lower temperature. This process is generally really fast because you know that electrons move easily, they move fast within the metal, so this can happen quickly. The second process does not involve electrons. It involves the metal ions because that's the structure of metals, right? Positive ions surrounded by a sea of electrons. So you have your positive ions, and in those positive ions, what basically ends up happening that those positive ions basically start to vibrate. As they gain kinetic energy, they start to vibrate. And as they vibrate, so the ions cannot move. The metal ions, the metal atoms, they cannot really move, right? They can just stay in their place and they can vibrate. The electrons could move. So what's going to happen is that they're going to stay where they are and they're going to start to vibrate. And as they're going to vibrate, they're going to pass on the energy from one atom to another. So the temperature can, so the energy can pass on from a region of high temperature to a region of low temperature. Now, when we are going to go ahead and talk about this, this second process, the second process where the atoms are responsible for transferring energy, this is a slow process because the atoms can't really move around. They can just vibrate around in their position, right? So what ends up happening is that they basically, what's going to end up happening is that they what's going to end up happening is this, that your electrons, the electron method is going to be the major process. That's going to be the major process. That's going to be the actual process that is going to allow the transfer of energy to take place. Okay, that's going to allow the transfer of energy to take place. The movement of atoms is not that significant. So the major method is basically your electrons. And that is how conduction actually takes place. And we can go ahead and we can actually test which metal or which substance is the best conductor of heat. Okay. So first of all, let's talk about conduction. Okay. So heat is conducted. When you talk about heat conduction, remember this: greater the cross-sectional area, the faster your heat is going to be conducted. Why? Because more electrons are able to move. The electrons are able to move more freely because the surface area is large. Cross-sectional area is larger. Because the cross-sectional area is larger, more electrons are basically able to move. And as a result, what is going to end up happening? That it is basically going to, heat conduction is going to be faster. Another difference is temperature difference. Greater the temperature difference between the two sides, the faster the heat conduction is going to be. So we can look at the conduction of heat. We can do an experiment where we can find out who is a better conductor of heat by actually doing an experiment. So over here, what we have done is that we have taken certain metals, and at the end of each metal rod, we have used a piece of wax to attach a matchstick. And then we have taken our, you can say, metal rods, and we have put the other end into the flame. Now, what's going to happen is this, that the energy is going to be transferred through the metal rod through conduction. It's going to be transferred through the metal rod through conduction. And whichever metal is the best conductor, it will conduct the heat fastest. So in that particular metal, what's going to happen? The wax is going to melt and the matchstick is going to fall down. So this is the experiment we can do to see which one of them is the best possible conductor of heat. In those situations, if you're doing this experiment, for example, in ATP or something like that, you have to remember that you need to keep the length of the rod same. You need to use the same cross-sectional area of the rods. You have to make sure the starting temperature or the room temperature of the rods was the same. And you have to make sure you're adding the same amount of wax to all of the rods as well. And all of them are being exposed to the same amount of heat. So when we are going to talk about it, we have, good conductors and we can have bad conductors, right? The good conductors of heat are generally, when you're going to talk about it, your metals are considered to be good conductors of heat. When you talk about bad conductors, we call them what? We call them insulators. They're known as insulators. And when you talk about insulators, you have to remember air is the best insulator ever. Air is a really, really good insulator. For example, if I want to keep a house warm, you know what you can do? You can actually take 2 layers of bricks, or we don't use bricks as such anymore, but just for example, make like one wall of brick and then another wall of brick. And between them, you have a layer of air. So that air is going to keep your house really protected. Your animals work in the same way when you talk about animal fur. So generally what happens is that they have 2 layers of fur. So the fur actually traps in the air. It actually ends up trapping in that air. And because the air gets trapped in the fur, it actually keeps them insulated. So we have got good conductors and we have got bad conductors. That is what we have to know about conduction. Now, that was in a solid. So how does heat energy travel in a solid? By the process of conduction. What about in a liquid or in a gas? What will happen in a liquid or in a gas? How is the heat energy going to be transferred? It's going to be transferred by a process known as convection.
Miss,
What? Yeah.
Miss, you mentioned that when the positive ions start to vibrate in place and that passes energy. Is that related to conduction or convection?
No, that is conduction. The movement of the electrons and the vibration of the atoms, both are conduction. So in conduction, 2 processes are taking place. The vibration of the atoms and the movement of the electrons. Both are in conduction. So conduction happens in two ways, but the vibration of atoms is not as significant as the movement of electrons. The vibration of the atoms are also responsible for transferring heat energy, but it's a very slow process. The major process in the fast process is the collision of electrons. So both of these are for conduction. Okay.
Right. Yes.
Then we have convection, right? When we are going to go ahead and talk about convection. So convection is the process by which what is going to end up happening, that you're going to end up the thermal energy is going to transfer in your liquids and in your gases. Okay, so let's go ahead and discuss this. How does this actually happen? The way your convection currents work is, let's consider okay, an air conditioner. So when you talk about an air conditioner, why is it that we always place an air conditioner at the top of a room? Why do we never place it at the bottom of a room? There is a reason for that. So what happens is this, that your air conditioner is going to start cooling the top of the, I place my air conditioner at the top. So what's going to end up happening, that the top layer of my air, the topmost layer is going to end up becoming cool. And since the topmost layer is going to end up becoming cool, what's going to happen? Cold air is dense. Remember that. Hot air is less dense. Cold air is more dense. So what's going to happen? The cold air is going to sink towards the ground because it is more dense. So the cold air is going to sink towards the ground. This is what you will see. This is my air conditioner. So what's going to happen? This is my cold air. So my air at the top is going to get cold. When the air at the top is going to get cold, it's going to become more dense and it's going to start moving towards the bottom. As it is going to move towards the bottom, the hot air is less dense. So the hot air is going to rise to the top. So the cold air has come down and the hot air is now risen to the top. Now what will happen? The hot air will be cooled down by the air conditioner and it will become more dense because it will now be cooled. It will now be cooled, it will become more dense. Again, it will go to the bottom and the air at the bottom, which had now become a little bit hot, it will again go back up and it will become cool. And this current is going to be set up. This is known as convection current. Okay. Similar thing can be observed if I take a look at a heater. A heater is always placed at the bottom. Why? So what the heater is going to do is, the heater is going to heat up the layer at the bottom. Since the heater is going to heat up the layer at the bottom, you know that hot air expands, right? Hot air is going to expand. And since hot air is going to expand, what's going to happen? It's going to rise towards the top. The air at the top is at the moment cool, right? The air at the top at the moment, it is cool. So that air is going to start to sink to the bottom and the hot air will go to the top. So the cold air will sink to the bottom and it will be heated up by the heater and it will end up becoming warm. Again, the warm air is going to rise to the top and the cooler layer at the bottom will come at the below. This is going to end up setting a convection current. Same thing you are observing over here. I'm heating it. Okay, I have put a crystal for potassium magnate in my water and I'm heating it. So I will end up observing that my potassium magnate is traveling in a convection current. Why? Because the water at the bottom is getting heated. The water at the bottom is getting heated. And as the water at the bottom is getting heated, it will expand, it will become less dense, and it will rise to the top. The water at the top, which is cooler, it will start to come over here at the bottom because it is more dense. The water at the bottom is going to get heated up. The water at the top will become a little bit cool. And again, the water at the bottom will move up to the top and water at the top will come back to the bottom. This is going to set up our convection currents. Making sense?
Yes, miss.
Okay. So the way you define convection is basically flow of heat energy through a fluid from high temperature to low temperature by movement of the fluid itself. The liquid itself, the water itself is moving, right? The air itself, the gas itself is moving. It's rising, it is sinking. In conduction, the metal was not moving. The electrons were moving, yes, but the metal was not moving. The metal was staying where it was. In convection, the free heat energy is going to flow from higher temperature to low temperature by movement of the fluid. The fluid itself is going to move and it's going to allow the transfer of heat energy to take place. This is exactly why during the day, if you've ever been at the sea, during the day, the sea is cold and the land is nice and warm. But during the night, the land is cold and the sea is warm because of convection currents. That is the second method that we can go ahead and use. Now, the third method that we have is radiation. The thing about conduction and convection is that you need some sort of medium, you need some sort of matter, you need some particles, you need some sort of medium to be present so that heat energy can be transferred. But radiation can even happen in a vacuum where you have no particle whatsoever. So for conduction, you need to have some sort of solid. For convection, you need to have liquid or gas. But radiation can happen even in a vacuum where there is no air available either, right? In fact, radiation is how we get heat energy from the sun. So you know that the sun produces what? Ultraviolet radiation. What is ultraviolet radiation? It's an electromagnetic wave, right? It is an electromagnetic wave. And when you're going to go ahead and talk about it, ultraviolet radiation is the radiation produced by the sun. Generally, when you and I are going to talk about radiation, we're going to talk about infrared radiation. Okay, infrared radiation is also radiation that is infrared radiation is what we're going to be talking about, because ultraviolet radiation is only going to be present when an object is extremely hot, like the sun. You need to have really high temperatures to produce ultraviolet radiation. So generally when we're heating up substances, we are producing what? Infrared radiation. So what actually happens? How does radiation actually work? So radiation involves electromagnetic waves. Now, what is going to happen that, let's say that, let's say that, when you're going to talk about it, that infrared light is falling onto, for example, for example, it's falling onto a piece of metal. Now, what's going to end up happening is this, that the piece of metal is going to absorb some of that infrared radiation and it's going to reflect some of that infrared radiation. Some of that infrared radiation is going to be absorbed, some of that radiation is going to be reflected, and some of that radiation will simply pass through. So the part of the radiation that is absorbed, that is going to cause the increase in temperature of the object. When you're going to talk about it, what is radiation? Radiation is the flow of heat from one place to another by the means of electromagnetic waves. So when you're using electromagnetic waves and it is allowing heat energy to transfer from one place to another, that is going to be known as what? That's basically going to be known as your radiation. Now, when we are going to go ahead and talk about it, this is where we have to remember who are good conductors of radiation and who are good emitters of radiation. Remember this, who are good conductors of radiation, who are good emitters of radiation. And when you are going to go ahead and talk about it, so you need to know good emitter, bad emitter, good conductor, bad conductor. So let's go ahead and consider the situation. Remember this: dull surfaces are better absorbers than shiny surfaces. So a dull surface is going to absorb more heat energy compared to a shiny surface. And dark surfaces, for example, a dark color like black color will absorb more infrared radiation compared to a bright surface like a white color, right? That is why generally if you take a look at cars, so those cars that are painted black, they tend to be hotter as compared to those cars that have been painted white. Why? Because the cars that have been painted black, black is a good absorber of heat, good conductor of heat. So it absorbs that heat and it basically, the car tends to get hotter. So dull black surfaces are good absorbers of heat. White shiny surfaces are bad absorbers of heat. And just like that, we need to talk about emitters. So the same principle apply. Whoever is going to be a good absorber, they're also going to be a good emitter. So dull black surface is going to be a good emitter. Shiny white surface is going to be a bad emitter. So shiny white surface are a bad emitter because they basically reflect the heat. Instead of absorbing it, they're going to reflect it. And when you talk about a vacuum flask, for example, you can see that a vacuum flask is basically going to you can see how it has been made in such a way that it can keep your food hot. So it prevents loss of energy by all three methods. It prevents loss of heat energy by all three methods: conduction, convection, and radiation. So if you're going to take a look over here, first of all, you're going to notice that it is what we're basically doing is that we make it double walled, and in the middle we put some air. Actually, we don't put some air, we put some vacuum. Okay, so first of all, I'm going to make it double walled. I'm going to make it of glass and I'm going to make it double walled. So what is that going to do? First of all, by making it glass, we know glass is a bad conductor of heat. So that will make sure that there is no heat loss because of conduction. Secondly, I have taken two layers of glass and in between them, I have put some air. What is that going to do? Because in between them, I've put I've put a vacuum. Because there is vacuum present between the two glass surfaces, what's going to happen? That convection cannot occur, because for convection you need to have some sort of gas or some sort of liquid. So since between the two layers of glass I do not have any, all I have is vacuum, what's going to end up happening? That basically convection is not going to occur. And then to minimize the radiation, I have painted the surfaces silver. I've painted them silver because silver is a bad conductor and a bad emitter of heat. So this is how you can go ahead once you have the knowledge regarding conduction, convection, and radiation. You can use this information to figure out how to insulate different objects. Okay, that is it. We're basically done with the topic of conduction, convection, and radiation. Any confusion, anything you want to ask?
No, miss.
Okay, so let's go ahead and take a few look at the questions related to the topic of what we have just covered. So the first question states, a solar panel is mounted on the roof of a house. Figure 4.1 shows a section through part of the solar panel. A pump makes the water flow through the copper pipes. The water is heated by passing through the solar panel. State and explain three features of the solar panel that maximize the final temperature of the water. This is a 4 mark question. Okay. So go ahead, take your time, jot down the answer. You can type it over here in the chat if you can, and we will go ahead and discuss the points. So all you have to do is remember conduction, convection, radiation. You have to remember what things you can do to basically maximize. Over here you want to maximize the fine temperature, so what things can you do to make sure that you're absorbing as much heat as possible? Remember your three methods. Okay, conduction, convection, radiation. So how, what can you see over here that is allowing convection to happen, that is allowing radiation to happen, that is allowing conduction to happen? So think of those features, you have to select them and you have to explain them, and list down your answer, and then we'll discuss the points. Okay.
Yes, I resent my answer in the chat.
Okay, let me go ahead and take a look. Okay. You have a glass sheet, you're saying, that traps the heat radiation from the sun and won't allow the heat to be lost in the surrounding. Okay. Copper pipe painted black, good job. Black is a good absorber of heat, so it will absorb radiation from the sun. Okay. Insulating material. Copper is a bad conductor, so it won't allow heat to escape. Yeah.
It's the last paragraph that I sent.
Oh, okay. Okay, last. Okay, got it. Glass sheet traps the heat radiation from the sun, won't allow the heat to be lost in the surroundings. Copper pipe painted black. Black is a good absorber of heat, so it will absorb the radiation from the sun. Good. Copper is a metal, which is a good conductor, so it will allow the heat to be absorbed and pass into the water. Insulating material will allow the heat to be absorbed only by the copper pipes and won't let the heat be absorbed by the surroundings. Okay, so a little bit of things that you can go ahead and add. So when you're talking about copper being a good conductor, so you can go ahead and say, since copper is a good conductor of heat, so it will allow the heat to be absorbed by conduction and passed on to the water. Just like that, when you're saying black is a good absorber of heat, you're going to say, so as a result, it will absorb more heat because of radiation. Okay, just like that, the insulating material will prevent loss of heat, will reduce loss of heat by conduction. The trapped air in the glass will prevent the loss of heat by convection. So just like that, if you just mention the methods over here, that would be great.
Great.
Okay. Take it, give this question a read and let me know what you think should be the answer to part one.
For the first one, glass is a bad conductor of heat, so it won't allow thermal energy to pass through
Correct. What about the second
by
one?
conduction. The glass walls are coated with. No, wait, sorry. The glass walls of the flask have a shiny silvered coating. The shiny silver coating reduces absorption of heat.
Good job. Take a look at this one. If you want, I can scroll up as well. If you want me to, let me know.
Miss, could you scroll up?
Yes. Oh, sorry. Here you go.
A cap or a stopper on the top to prevent heat loss by evaporation.
Yes. Good. Heat loss by convection. It won't be evaporation, it'll be convection.
Convection. Miss, but it's for 3 marks, so should we mention like 3 points or?
No, I think if they're just saying suggest with reason. So maybe like two at the very most. You don't have to mention three. So if you just say add a stopper or add a lid on the top to prevent the heat loss by convection, that is good enough. But if you want to mention one more, you can also say that use an insulating material around the glass flask to prevent heat loss by, for example, radiation, or to prevent heat loss by convection.
All right.
Okay, take a look over here.
This for convection, can we mention that there's no fluid around the...
No, convection currents can also happen in air, remember? I told you it's between fluids and gases. Because otherwise, how could you get a convection current with an air conditioner or with a heater, right? We don't have any fluid in the room, it's the air currents.
Miss, I'm not sure about the convection one.
For the first one, convection, that is because when the air is going to heat up, what does it do? It rises up. It's not going to go sideways. It when the air is going to heat up, it will simply move upwards instead of going sideways. So of course your hand is not going to get heated up. Okay.
All right, Miss.
Okay. What do you think about the next one?
Conduction occurs by free moving electrons. So when atoms vibrate in position, the hand and the copper sheet are...
That's sorry. No, that's not the reason over here. I'll tell you that.
This won't it be because the hand and the copper sheet aren't touching each other? So the
Yeah, you're
electrons
close.
won't.
Close. You're close, but you have to put it in physics terms. It is because there is air between the copper sheet and hand, and air is a bad conductor of heat. That's why.
All right, Miss.
Now they're saying state and explain which hand gets hotter.
The left hand, because the side of the copper sheet is painted black, so it's a good emitter of heat, while polished is
Good
black.
job. Now take a look at part C.
Because of conduction, that...
Yes, exactly, because of conduction. So if one side is going to end up becoming colder, then because of conduction, immediately heat energy should transfer from high temperature to low temperature, and the temperature should equilibrate. It should become equal. Okay, take a look at this one.
the polished surface will lose in lose thermal energy more quickly as black is a wait no. The black surface will lose thermal energy more quickly as black is a good emitter, while the polished surface will lose it slowly as it's a bad one.
Yes, now you're correct. Okay, take a look at this question on the part B, and this is a 4-mark question. You have to describe the experiment he should carry to test out your answer at A. So in A, you said that black is going to have a faster rate of loss of thermal energy. So you have to now think of an experiment that you can do. This is a 4-mark question, so just go ahead and type out your answer, and then we will discuss it.
All right, miss. Miss, I've sent my answer in the chat.
Let me go ahead and take a look. Okay, so pour the hot water into 2 cans at the same time and record a reading of the temperature of the water using the thermometer. Keep the 2 cans in the same temperature for at least. How can you keep the 2 cans in the same temperature?
Like outside temperature.
Oh, then say keep the 2 cans at room temperature. Just say it like that. Because right now, the way you've written, I think that you're trying to maintain the temperature, like you're trying to make sure that the temperature remains the same. That's the impression your sentence is giving me. Okay. So, yeah, you can say try to keep the surrounding temperature equal for both of them. Right now, what I'm getting is that you're saying that whatever temperature it is right now, keep the cans at the same temperature, so that of course will not cause any heat loss, right? So
Right.
just might want to change your wording and record the temperature change after every hour. Record the readings in a table, and using a table make a graph of temperature and time taken. For both the graphs, control variables will be the volume of the water, temperature outside the can, of the water after 3 hours. Okay, when you're going to go ahead and talk about over here, you have written that you will control volume of water. One thing you can mention is that make sure you put a lid. You didn't put a lid. Because you didn't put a lid, so now heat loss can happen because of convection. So you can't be sure that the results you're getting are only because of the black surface or the shiny surface. It could be because of convection. So you did not add the concept of putting a lid. Also, make sure that the thermometers are not touching the can. Because if the thermometers are touching the can, they will record and they will record the temperature of the can, the metal. So that will also affect your results. And also you have to make sure that in both of the cans, the thermometer is placed in the same position. Okay.
All right, Miss.
Okay, take a look at this one.
She can put the tiles beneath each can. This will prevent the heat from the ground to reach the cans.
Yeah, good job. It will prevent loss from the cans onto the table. You can also use the tiles as lids, by the way. Okay, take a look at the next one.
The black, the can with a black surface heats up quickly, as black is a good absorber of heat.
Good. Okay, hold on 1 second. Okay, go ahead, take a look at the question.
First, it's conduction from the water to the walls of the tank. And then by the help of radiation, there's heat energy from the walls of the tank transferring to the air.
Yeah, good job.
Should we mention convection as well?
Yeah, you are going to mention convection. So you are going to say that from copper to the water, it is going to fine. It's going through conduction. That in the water, how is the water going to get heated up? The water is going to get heated up by convection. And then from the heated up water, the heat energy will pass onto the air through radiation. Okay.
Right.
Now take a look at the next one.
As temperature falls, there's less kinetic energy in the molecules, which will decrease the vibration of the molecule.
Actually, this can also be because of the reduced difference in temperature. Remember, I told you that greater the difference in temperature, the higher the rate of conduction. Remember, I told you that. So, when you're going to talk about it, since the water temperature has fallen, so there is less difference in temperature. So the rate of heat energy transfer is also going to decrease. Okay.
All right, Miss, but like, won't the other one work as well, or will it be just for conduction?
No, it will be for everything. Just like, when you talk about diffusion in biology, so it depends upon the concentration difference. So this can be applied for everything.
Right. Yes.
Okay, Monami, we'll go ahead and we will stop it over here for today. Okay. And